Have you ever been jolted awake by a shaking bed only to realize the entire room is moving? This is a common experience for those living in seismically active regions, a startling reminder of the unseen power beneath our feet. What you're feeling is the result of an incredible force, one that originates deep within the Earth's crust. This crust is not a single solid piece. Instead, it's divided into large sections known as tectonic plates. These plates are like giant rafts, floating on the semi-fluid layer of the Earth's mantle, and they're constantly moving, albeit very slowly. Imagine two massive slabs of rock, each many miles thick, sliding past each other. They creep along at a pace slower than a snail's crawl, but the sheer size and weight of these plates means that even this minute movement generates enormous stress. And when that stress finally becomes too much? So when you feel the ground shaking beneath your feet, it's the result of these tectonic plates on the move. But what exactly happens when these tectonic plates cause an earthquake? Let's dive into this geological mystery. Our planet's crust is made up of several mammoth slabs, known as tectonic plates. These plates are constantly moving, albeit at a pace slower than a snail's crawl. But sometimes, they get stuck due to the friction between them. Imagine holding a rubber band tightly between your fingers and pulling it back. The more you pull, the more tension builds. Suddenly, when the tension becomes too great, the rubber band snaps, releasing all that pent-up energy. That's quite similar to how an earthquake is born. When the tectonic plates finally slip past one another due to the immense stress, they release a massive amount of energy. This energy then travels in seismic waves, rippling through the Earth's crust and creating the shaking sensation we associate with earthquakes. In essence, an earthquake is the Earth releasing pent-up energy from within its crust. But how do we know how powerful an earthquake is? It's all thanks to clever devices known as seismographs. These intricate instruments record the intensity or strength of an earthquake by tracking the seismic waves that ripple through the Earth's crust. The stronger the waves, the higher the intensity, and the more dramatic the scribbles on the seismograph's paper drum. But we don't just measure intensity, we also gauge magnitude, or the total amount of energy released by an earthquake. This is where the Richter scale comes in. Named after the seismologist Charles F. Richter, this scale assigns a single number to quantify the energy an earthquake unleashes, and it goes from 1 to 10. However, it's a logarithmic scale, meaning each whole number increase represents a 10-fold jump in energy. So, the next time you hear about a magnitude 6 earthquake, you'll know it's 10 times more powerful than a magnitude 5. But why should we care about understanding earthquakes? It's not just a question of scientific curiosity. Our very survival could be at stake. Earthquakes can cause unimaginable devastation. Buildings, once standing tall and proud, can crumble to the ground in mere seconds. Landslides can sweep away entire communities, forever altering the landscape. And let's not forget the tsunamis, those monstrous waves that can be triggered by undersea quakes, causing destruction along coastlines miles away. But it's not all doom and gloom. With understanding comes the power to mitigate. Research into earthquakes helps us better understand where and when they might occur. This knowledge can inform engineering practices, leading to safer, more quake-resistant buildings. It also aids in disaster preparedness, ensuring that communities know what to do when the ground starts shaking. So you see, understanding earthquakes is not just about satisfying our curiosity, it's about saving lives and communities. It's about ensuring that when the Earth shakes, we're ready to stand our ground. We live on a dynamic planet that is always changing. As we've seen, the Earth beneath our feet is in constant motion, with tectonic plates shifting slowly over time. This movement, while usually imperceptible, can sometimes lead to the sudden release of energy we experience as earthquakes. From the subtlest tremor to the most devastating quake, these natural phenomena demonstrate the incredible force of our planet. Earthquakes are measured by seismographs, and their intensity is quantified on the Richter scale. This understanding helps us grasp the might of these geological events and their potential impact on our lives. The effects can indeed be catastrophic, causing buildings to collapse, triggering landslides, and even generating tsunamis in coastal areas. But knowledge is power. By understanding the forces at work beneath the surface, and through continued research and engineering, we can mitigate the damage caused by earthquakes. Preparedness is key to ensuring the safety of communities worldwide. Thank you for joining us on this exploration of earthquakes. Until next time, stay safe and keep learning about our fascinating world.